Welcome to Star Talk Radio. I'm Neil deGrasse Tyson, your host and your personal astrophysicist. I'm also director of New York City's Hayden Planetarium at the American Museum of Natural History. Tonight, we give you the final episode of Star Talk's 8th season. It's part 2 of our annual Time Capsule. Of course, we sent out a survey to you, our fans, and you got back to us with all your favorite episodes, favorite co-hosts, and guests over the year. And we used those data to choose which episodes to splice together in the single potpourri of Star Talk's best moments. This week, we focused only on our Cosmic Query episodes. You sent in your queries about the cosmos, and I did my best to answer. On your number 1 favorite Cosmic Query episode, according to your votes, we took your questions about all things space-time. My comedic co-host was the one and only Godfrey. Check it out.
You ready?
Yeah, go.
This guy, he's an interesting last name. Jeff Sosterek. Sosterek. It might, because it's like, I think it's Polish. Sosterek. I don't know. He's from Bethlehem, Pennsylvania.
Gotcha. Mm-hmm.
Is there anywhere in the universe where you can find a
Usually, yes. No matter what follows in that question, the answer is probably yes. Okay? The universe is large, it's old, and stuff happens in the universe.
Where you can find a zero state of energy, perhaps where even the cosmic background radiation does not permeate. Man, these questions are something else.
Ooh, so that would be an absolute zero. As far as we know, the vacuum of space is a seething ocean of what we call virtual particles that are predicted by quantum physics. And quantum physics has been right in every other way it's ever made a prediction. So we have high confidence that what it's saying is true. But as long as you have particles, even in the vacuum, there's going to be an energy level there, and you never actually get to perfect zero energy because of the quantum. And so the quantum prevents it. We would need some higher theory of understanding of the universe that might enclose quantum physics, right, that will enable us to get to places that our current understanding does not. But right now, there's no way to get to a perfect zero energy because every state, even the zero energy state, has a probability of having real energy. Wow. Quantum physics requires it. Yeah.
Nah.
Yeah, quantum physics, everything bows to quantum physics.
Always.
At the end of the day.
Oh, yeah, invisible math, man.
Where you get this from? Invisible math. There's math that can describe invisible things.
That's what I mean.
But the math itself is not invisible.
I like calling it.
Where are you getting this?
Math.
No, I'm not
invisible, man.
I'm not accepting it.
Mathematicas de invisibilidad. Nothing.
I'm not going there.
No, you don't like to call it invisible math?
No.
Just
because you don't understand it doesn't mean it's not there.
Well, I call it's invisible to me because I don't want to see it.
Okay, because you look the other way.
That's why I call it invisible because I suck at it.
Here's the fun part.
I suck at it.
We observe weird stuff happening in the lab.
Yeah.
And for people who hate math, this must freak them out. Oh. So we have scientists of the day saying, let's attach math to this to make it easier. So we can bring some understanding to it. So the mathematics of quantum physics is an extraordinary achievement of the human mind.
Yeah, that's another brain that's something I don't have that.
No, but maybe you did, and it still has to be found.
You think that I could bring that out? I can get good at quantum physics?
I think
the mathematics?
We can always get better.
No, I think
whether or not we can become great at anything, we can always become better at it.
You're naturally good at math. I think it's a natural knack. It is. There's people I knew in grade school, like some guys I knew and girls that would just they didn't even study. I had to use the teacher's example and flip the page over to do a math.
Look at the answer in the back of the book.
My friends were just certain guys. They were just naturally good at it. You know that. Come on, you're naturally good at math.
I spent a lot of time at home reading books on math. Does that mean I'm naturally good? Does that mean I'm naturally curious and I happen to apply that curiosity to math and therefore got higher grades in math than you did? What were you doing when you went home after school?
I was confused. So I just kept watching cartoons, man. You know what I mean? And there's stuff that you were reading, you were probably reading.
I was reading
theoretical stuff about mathematics.
I was reading math, yeah, I was reading.
You naturally have an inclination for that because you were naturally gifted for math. That's what it is.
I had curiosity in childhood that never left me.
Guess what I want? I watched comedies, man.
I love
You love comedy too? You're a funny guy. But but I continued my funniness in that way, comedian. You, funny guy, but astrophysicist. Because you're amazing at math and invisible math. Because you see the invisibility of it. Okay.
All right, you made your case.
Are you ready?
Yeah, what's the next question?
Yeah. Nicholas Lambert, Facebook. Why is dark matter presumed to exist when modified Newtonian dynamics is able to account for most of the missing mass? Have physicists forgotten the principle of Occam's razor?
Occam's razor.
Right.
So Occam's razor, there was I think it was Earl of Occam.
Okay.
British fellow.
Right.
I think he was British, who uttered the following words: multiplicity ought not be posited without simplicity.
Okay.
Which is, what he means is, I think I got that quote right. What he means is, if you have an explanation for something that is long and complicated, and someone else has a really simple explanation, the simplest explanation is probably the correct one.
Gotcha.
That's all. Okay? So, for example, let's take epilepsy.
Okay.
Before we understood epilepsy, there you are writhing on the ground, and so people had an argument for it. Well, the creator of the universe, in the Judeo-Christian tradition, has a nemesis called the devil, and that devil has occupied the body of this particular person because of the things this person has done.
Right.
Okay? Or the brain is misfiring in its neurosynapses. Okay? So this is what we're contending with.
Right.
Right? So there you have it. So in the movie The Exorcist, it's like, this is the 21st century, the 20th century, I think. We got this one. All right. So the notion there is there's if you modify Newton's equations of gravity, then you don't need to posit dark matter to explain things in the universe. And it would mean that our understanding of gravity was flawed in this way, where when we corrected it, we wouldn't need to invoke this magical, mystical thing called dark matter. And so it turns out you can modify Newton's laws of gravity to explain some of the places where dark matter was otherwise invoked. There are other places where it fails completely, and we have no way around that. We don't, with the you can't modify Newton's gravity in the same way to account for it. And so that's why we all haven't jumped on the bandwagon adding terms to Newton's equations of gravity. That's why.
Awesome. Awesome. I'm going to keep going.
Okay.
I like that one.
Go for it.
Here we go. Adrian Gray Martson from California.
California.
We currently can only go forward in time with regards to black hole technology. Technology. Whoa.
Nice.
Given what little we know about dark matter and dark energy being our physics opposite, do you think our future insights and education on all things dark will grant the option to move backwards in time?
Ooh,
all things dark.
Man.
All right.
And black hole what is it? Black hole tech.
There's black hole technology.
Technology. Okay,
Wow.
So it turns out if you can warp the fabric of space and time. By the way, I have been told this. I have not double-checked the math. But these are people whose math, in other cases, I trust implicitly. So that there's a configuration of curved space-time where if you go around a black hole in a particular trajectory and come back around another one, you can actually go back in your own space-time. And so effectively go backwards in time.
Okay.
But it's still a little bit mysterious to me. Okay, I got people who do this. I'm not the one who does it.
Right.
Okay. As a colleague of mine, J. Richard Gott III, who I actually am co-author on in a book that was just released.
Right.
Princeton University Press.
There it is. What's the title?
The title is Welcome to the Universe.
Yeah.
An astrophysical tour.
Ow!
Just at a local bookstore near you.
I'm going to get it.
So in there he talks about these solutions to Einstein's equations where you go back in time. But they involve very exotic trajectories. The point is, the bigger point of the question is, we've got dark matter. We don't know anything about it. Dark energy. We don't know anything about it. And who knows what else we don't know anything about.
Right.
That's kind of the fun part of not knowing about something. Not even knowing that you don't know about something.
Right.
Okay. So with all of this, could it be that once all of that's figured out, we could have access to the past? I can't rule that out. I will not rule that out. Almost everything we've discovered that came about from profound ignorance has transformed civilization. Think about the discovery of electricity, what it has done.
Yes.
It's probably the greatest thing to ever happen to civilization.
I can't even imagine not having lights. I can't even imagine not plugging stuff in.
Flicking a switch.
Flicking a switch.
Right.
Don't know how it works, don't care, it's here.
It's not even, and we've made it into something that's not even only about light. Movies, just everything. Okay, so this is harnessing something that previously we ran away from or didn't understand. So I look forward to a future where dark matter and dark energy come to be understood. But then that only puts us in a new place to stand, possibly observing new unknowns that today are yet to be dreamt of. Every now and then, fan queries are related to a specific topic outside of my expertise. And so I got to call in an expert or two to help delve in a little bit deeper. Such was the case with one of your favorite episodes of the season about higher dimensions. Joining me in studio was mathematician and good friend John Allen Paulos. And via Skype, we had physicist and superhero expert James Kakalios. In the Star Talk co-host seat for the first time was comedian Harrison Greenbaum. Let's take a listen. Bring it on.
All right.
Bring it on. And I got two experts here. I could just go to the Bahamas right now because we got all the expertise you need for higher dimensions, and so much of people's access to higher dimensions and knowledge of higher dimensions comes from superhero movies. So let's see what you got.
Yeah. So the first question comes from our Patreon. So thank you for
Patreons, okay,
for supporting us. And this one is from Orlando, Florida. So he's near a superhero theme park. We've seen compelling theories that postulate everything from 4 to 26 dimensions in our physical world. What's so special about the fourth dimension? Is there anything mathematically unique about it compared to what we consider spatial dimensions?
It's physically, there are arguments for it. As I said, the second law of thermodynamics suggests that once the early universe cooled a bit, it didn't have enough energy to
birth out another dimension.
Burst out another dimension if you wanted the second law to hold. So the fourth is beyond us. But
you're saying we're stuck with 4 dimensions?
We're stuck with 3 and 1, 4 dimensions. So, there are these other, deficient, for lack of a better term, dimensions if you believe in string theory. But,
Okay.
That's. There are lots of theories. Kant had his own theory, but I don't want to get into Kant.
Immanuel Kant.
Immanuel Kant.
Okay, yeah. But he didn't know anything about cosmology.
No. Well, one thing he did, he made a distinction that many people derided between noumena and phenomena. Noumena is the way things are that we'll never know. Phenomena is the way we see things. We are a priori categories. And in a way, the string theory is something we'll never know. And the extra dimensions and other universes we'll just never know.
In physics, we don't give a rat's ass about what something is if what it is not revealed to us through a measurement.
Yeah, but...
would you agree with that?
I would. It is kind of disturbing that of all the extra dimensions, none of them are in the time domain. They all seem to be extra spatial dimensions, because if they were in the time domain, then maybe we could move back and forth in time the way we move back and forth in space. And in fact, science fiction stories have sometimes suggested that would be how time travel would occur.
So help me on this. So if we had more than one time dimension accessible to us, does that mean we can just go off in one time coordinate while freezing our movement in the other time coordinate and do things with our life and then return and then continue? Because that's what I do spatially.
Why not? No, presumably that would be in fact the case.
That's kind of
right.
Cool.
So that I can't remember where. It might have been even an H.G. Wells short story about that might be a way of achieving time travel, that they discovered that there's other pathways, just so you can get from one point to another taking alternate routes.
Alternate time routes.
You could spatial routes. We do it all the time.
Right.
So
I see.
That you could
you'll take a shortcut. You'll do everything.
Right.
You'll go backwards to where you once were. You'll visit your old haunts. Yeah.
It's like a time shortcut.
Yeah. So you could have a time shortcut, right? That would be interesting, but they never want to add another time dimension when they need to add dimensions.
But is this anything different from the wiggly wobbly timey-wimey time of Doctor Who?
I think that ultimately the reason why there are only extra spatial dimensions is in fact just that, to avoid saying, well, they kind of postulate time travel is not going to happen, so everything has to stay, all the extra dimensions are spatial.
Well, time travel always leads to the grandfather paradox. You go back in time and kill your grandfather. Unless the universe splits there. In one universe, your grandfather...
That's the many worlds. So that's the many worlds. That's right. So you can go back in time, but it's an alternate, so you can kill as many grandfathers as you got bullets.
Yes. And would Trump be president? There's nobody who's using their time travel to come back and be like, what are you doing?
I'm working on it.
All you have to do is prevent your grandfather from meeting your grandmother. Yeah. Then you won't be born. Or delay when they had sex by 10 minutes.
There's this guy with blood on his hands. He's like, you just had to go to the library. Knock a book out of his hand. Oh, my God.
All right, let's go to the next question. What do you have?
This gets us to our next one. From Justin Collado in Facebook. How much cannabis do I have to smoke to get to the fourth dimension?
Ooh.
I'm assuming he's in Seattle.
Experts.
Or Colorado.
Or Colorado.
Yeah, we got good places for that.
What are you looking at me for?
No. Okay, so John, when you get deep into your math, how much cannabis is required to reach different dimensionalities in your analysis?
I don't know.
No, don't know. Okay. Okay, so that's an experiment that you could perform.
Yeah, well, in my particular case, it'd probably be a tiny amount since I don't ever engage in such. So I think a tiny little bit, and I'd be in the fifth dimension.
Okay. And
time slows down when I use it, so that's a way of changing the fourth dimension.
Right. Slows down for you.
For me,
yeah. Rest of us are looking at you
my friend.
Oh, your friend.
Yeah,
slow down for your friend
in Colorado
who smokes.
Yeah. I don't know anything about that.
All right, next one.
All right, cool. This is from the Star Talk website. Gary F. Anderson, he said, supposedly before the Big Bang, dimensions didn't exist. When the Big Bang manifested itself, dimensionality suddenly came into existence. Did that dimensionality expand at the speed of light, or did it just instantly pop into existence, creating an infinite empty universe?
Well, everything we know says that we were endowed by the matter, energy, space, and dimensionality from the transition from an extremely high temperature universe to one that's much cooler, and we're freezing out these properties as the universe expands and cools. Wow. So James, would you add or subtract anything from that account?
Not at all. I'm a humble but lovable solid state experimentalist. So,
don't blame me for this Big Bang stuff.
No. But this is not my area of expertise, so I will defer.
Yeah. So I mean, you get this at different stages of the extremely early universe, and so we're stuck with the universe we have. Get over it. Next question.
That's fair.
Got time for one more before we take a break. Go.
Yeah. Green Meteor from Instagram said, "Is death the fourth dimension?"
Ooh.
Seem like more the zeroth dimension. you just disappear.
That's good. Yeah, I would agree. Death is the zeroth dimension.
Yeah, I'm going with that.
You're going with that. We got three.
It works for me.
3-0 here. We're going with it. Okay, so we got another one. Bring in another one.
Richard Adams on Facebook says, "Do accounts of powerful deities make more sense when you consider higher dimensions?"
Ooh.
Well, when you think about like the flatland example, that if we lived in a flat dimension, a three-dimensional person who could put things in and out of our flat dimension would seem, extra physical, would seem beyond our realm or our understanding.
And isn't that what Thor is to Earth? Thor exists in higher dimensions. They have access to space-time dimensions that we don't. Isn't that correct?
Presumably.
Well, you're my comic book guy. Don't tell me presumably.
But they've gone back and forth on that of saying, oh, it's magic, or saying that there's a scientific, it's just like hyper science, or back to it's magic. So,
but I think the takeaway here is that it's clear that if you live in a higher dimension relative to some community of beings, you are all powerful and all knowing in ways they will never understand or imagine.
Yeah, I think that's right.
So
I think that's right.
The answer is yes.
The answer is
Yeah,
yes.
I think the answer is basically yes.
Yeah.
Yeah, it's indistinguishable from what a high and deeply religious people will say God is knows all and is all powerful. They will ascribe powers to God that any of us would give to a higher dimensional being. If they, I think that would be trivial.
And we could have a hierarchy of gods too: the fourth dimension, the fifth dimension, sixth dimension.
Yeah.
So I just need to find a flatland and be God.
Is that your first thought? Is that what you really?
Yes, the cult of Harrison. There'll be a bunch of flatlanders giving me two-dimensional offerings.
Like the tiny insects you are.
Exactly.
Well, when we come back, more of Cosmic Queries on Higher Dimensions when Star Talk returns.
Would you like to listen to Neil deGrasse Tyson explain black holes or gravitational waves? Want to hear Bill Nye talk about climate change or GMOs? Did you know that you can search the entire Star Talk podcast network by subject or host or guest? It's easy. Just head on over to www.startalkradio.net and search for pretty much any scientific subject in the universe, and it's likely we've got something to say about it. Or as I like to say, if it's out there, we've got it in here. Did you like what I did there? Oh my God, I'm rhyming. I can't stop myself. It's just my timing. Oh, I am so sorry.
This is Star Talk.
Welcome back to Star Talk Radio. I'm your host, Neil deGrasse Tyson, and we're in the middle of our final episode of the 8th season. This is a special Time Capsule edition. We've reached back into the archive of Season 8. Yeah, we've been doing this for 8 seasons and extracted some of your best-loved moments, according to your votes. Your number one favorite comedic co-host this season, Chuck Nice, returns to serve up your smorgasbord of questions in the Galactic Gumbo edition of Cosmic Queries. Check it out.
Melissa wants to know this, coming to us from Chino Valley, Arizona. Hey, Neil, I'm curious about your thoughts on somewhat combining creationism with the Big Bang. Although I am agnostic, I was raised Catholic, and I always wonder why no one seems to consider that a possible higher power is behind the Big Bang and consequently dark matter. So do you have any thoughts on that? I mean, from a scientific standpoint, you cannot speak to this because you're speaking about, you know, the fact of a creator or some higher power creating this.
Oh, sure you can. If
you
science,
can.
Oh, well, so let me be clear.
Okay.
This, if there's a higher power that did anything in the universe, there's no reason why that should be beyond the ability of science to determine that.
Oh, okay.
All right?
Interesting.
So if you do science properly, you're not precluding any one explanation relative to another if you're on the frontier of discovery.
Right.
Okay? So I'm not going to say there is no higher power there, and let me find something else. If the higher power is there and it manifests, then my methods and tools find it, I'll be the first one to report it. Okay?
Right.
I'll be up right there at the front of the press conference. Okay?
Right.
So just to make that clear. And let's back up. This is a deep question here.
It is.
It's got more going on than she may even know.
Okay.
Okay? After Einstein advanced the general theory of relativity in 1916, it was, oh my gosh, the universe, there's gravity and it shapes the universe in this way. And then in 1929, Hubble discovers that the universe is expanding.
Right.
You take general relativity and the data that the universe is expanding, and a clever physicist named Georges Lemaitre,
Okay.
he was a Belgian physicist, looked at that and he said, wait a minute, if we're expanding and I have this new tool, theoretical tool to understand the whole universe, let's go back in time and ask, what would the universe have been yesterday compared with today?
Right.
It would have been smaller.
Right.
Let's go even smaller.
Even smaller.
Take it all the way back.
So we go all the way back. We got to get down to a singular point.
A singular point.
Right.
A beginning of things.
Right.
This person is a Belgian priest.
Oh.
An ordained priest.
He must have drank some good beer.
Belgian beer.
Mm-hmm.
So people immediately said, oh my gosh, you have found proof of biblical creation.
Oh, really?
They said this to him. And he, a Belgian priest, came all back in their face and said, no.
What?
Because the Bible says the universe was created in 6 days. The Bible says Earth was created before the sun. There's a lot going on in Genesis that is scientifically untenable.
Right.
But now you want to take just a little bit that said God created it and say, oh, therefore it proves the Bible when nothing else that follows it has any anchoring in observational science.
Right.
He was smart enough to know that this, when I say smart enough, he was sensible enough to know that this should not be invoked as evidence for God creating Genesis as described in the Jewish Bible, in the Old Testament.
Old Testament.
So, because nothing else works there.
Right.
Okay? Nothing.
Right.
Okay, Earth is in the middle of things. Everything revolves around the Earth. Earth is flat. So this goes on and on and on. So he knew enough about the Bible and about science to not make that connection.
Gotcha.
Okay. So now, by the way, higher power could be God, or it could be some intelligent alien in its basement programming our universe for its own entertainment. That would be a higher power.
Wow.
If you think about it.
Yes, that would be a higher power.
Yes.
That guy's really effed up, man.
Especially
if that's the guy, hey, dude, if you're in your basement right now.
Your parents' basement. It's the alien version.
You little pimply faced alien bitch, you. This is effed up what you just did.
Then I wonder if we are a simulation programmed by a higher power, maybe they get bored every now and then and they throw something to just throw in something in the mix.
A little glitch in the matrix.
Little glitch in the matrix.
Right.
You know, they throw down a disruptive politician or a world war.
Right.
Or
that would explain so much.
would completely explain it.
Oh, God.
Everything's going along just fine and tranquil. And they say, nope, you're not entertaining me anymore.
Lodite, watch this. Look at what I do right here. You know? Dog, how many times have I told you to stop screwing with those people?
But a broader reference to that question is, we don't know what happened before the Big Bang, and we also don't know what dark matter is, nor dark energy.
Right.
If you, and I've said this before, and listen to my words very carefully, if your understanding of God flows through places where science has yet to tread.
Right.
Because these are frontiers.
Right.
Before the Big Bang. If that's your concept of God, then the history of this exercise shows us that God would then be an ever-receding pocket of scientific ignorance.
Well, of course. I mean, that only makes sense because you're saying all these other things are provable and knowable. And so we know
these other things at one time in the past
they were not
mysterious. Correct.
Mysterious. So now that we know these are provable and knowable and why they happen, these phenomena are actually explainable, right? Then
your plural phenomenon. Your plural phenomenon.
Yes.
Phenomena. Very good.
Do you like that I actually corrected myself there?
Very good.
Yes,
I'm
thank you.
checking you out here.
That's cool. So and then you say, well, but what I don't know here. I just think that this is God doing this.
Philosophers call it the God of the gaps.
The God of the gaps.
Right.
So, in other words, wherever your understanding fails you fill it in with God.
Fill it in with God.
Okay.
And by the way, this is a long tradition to do so. Okay. Isaac Newton did it.
Oh, really?
Isaac Newton wrote down his equation of gravity, and it described Earth and the moon, and the sun and the Earth, and Jupiter and its moons. We would later learn it. So this is all. But how do you then describe the whole solar system all happening all at once?
Right.
Everything tugging on everybody in all directions at all different. And he tried to calculate this,
Right.
and the solar system was unstable, and planets would fly apart.
Right.
Because every time you came around the backstretch, Mars would tug on you a little bit.
Right.
You come around the next time, Mars would tug on you a little more.
Before you know it, you're out.
You're out.
You're out the door.
Yeah, we out.
Right.
Okay.
You in the Kuiper Belt going, it's cold.
That's right. So you would
God, it's
say,
cold.
so he said, well, clearly I know my equations work
Right.
with the one-on-one situation. With the whole system, maybe God steps in every now and then just to fix it.
And corrects things.
Yeah, and corrects things.
Right.
He says this
Right.
in his 17th century lingo.
Okay.
He says just that.
Okay.
And so that's basically God of the gaps. Next up, comedic co-host Godfrey returns to pitch me your cosmic queries about cosmic phenomena. All right.
I have another question.
Cosmic phenomena, bring it on.
This is by William Morris. Facebook.
Okay.
What's a hen weigh?
About 2 to 3 pounds. Next. You can't. What do you think? I was born yesterday? What's a hen weigh?
I just wanted to see that. What's a hen weigh? So there's no science behind that, huh? That's it. Next. That's it. What's a hen weigh?
We should call the first warp drive a henway. So that wherever they land, they say, we got to fix the henway.
We gotta fix the
What's a
henway?
henway? Oh, about 2 to 3 pounds. You could run that joke
Now that's
clear
nice.
across the galaxy.
That was awesome. What a jackass.
Well, this is I'm old enough to remember F Troop.
F-Troop, that's Larry Storch.
Larry Storch and what was it? It was like the cavalry,
Right.
and the Indians, right,
Right.
in the Wild West, and the name of the tribe were the Hakawi Indians.
Was it the Hakawi?
The Hakawi, and I think in the first episode.
You remember the first episode of F-Troop. Damn.
So I think. I think I'm remembering this correctly. In the first episode, the cavalry meets this tribe, and they say, "Who are you guys?" And the Indians say, "Where the heck are we?"
That's hilarious.
Yeah, I think that's how that happened in the very first episode.
Are we Indians?
Yes.
I just caught that again. So that's good. What's the
All right.
henway? You knocked that out.
Yeah, so I'm going to call. If I invent a warp drive, it's the Henway warp drive.
Henway Road.
Yeah,
I like
okay.
that. Ray Clark, Facebook.
Okay.
If the moon were to somehow be blown apart, would Earth end up with a set of Saturn-like rings?
Yes.
If not, what would happen?
Yes. Yes. Temporarily, we would have ring system. An awesome.
Awesome.
Yes, using awesome the way God intended awesome to be used.
Oh, yeah.
Not, it would be awesome if you could pass the salt. No. In my day, we used awesome when we discovered the cure to polio. We used awesome when we walked on the freaking moon.
Do you believe that? I don't know. We were talking about that. Do you believe that they landed? I just want to know.
You're asking the wrong.
I'm just saying, man. The astronauts should have been black because we would have been more excited.
Upon landing.
Because he was, yes.
They say, Houston, we have just landed on the
Like,
moon.
yeah, baby. Yeah. That's how we do, baby. Forget the cosmonauts. We did it first, baby. I'd be like this. No?
That's one small step for man.
Come on. You land on the moon and you go, one small step for man, one giant step for man. It's like when the white,
You know what it is?
It's like when the white dudes score a touchdown, they just give the ball to the ref. When we score, we're like,
Shake something.
yeah.
Shake something. Now, here's the thing. I think the emotions that would come about
Yes.
among people who would rejoice in having just landed on the moon
Yes.
are incommensurate with how you might react in the face of disaster if you face that on your journey. If the oxygen tank blows, holy shit, what am I going to do? Oh my God. Okay? That's the same person who lands on the moon. Oh my gosh, I landed on the moon.
Yeah.
So you need people with ice in their veins. Yeah. And Neil Armstrong was just such a person.
Okay.
Yeah.
Well, all right. I guess, but I just.
He's right. He's landed on the moon and he's running out of fuel. Okay, you know about that. I don't know if you knew about this.
We're running out of fuel.
He was because where they were going to land.
Right.
There was like rocky and it was not smooth, and he was worried that the lunar excursion module would tip.
Yeah.
So he starts going sideways.
Okay.
Using very little fuel that's left, and so Houston is saying, "You got to land that puppy." No, I'm going to still looking, and he's monitoring how much it is.
Yeah.
You know what his heartbeat was when it was like 85 or something. I mean, it was some low heartbeat that any of us get just when we're irritated that we're waiting in line or something.
Yeah.
So, no, these were a very special set of the right stuff.
Okay.
It was truly the right stuff.
How long did it take to get there?
3 days.
It was 3 days.
Yeah, 3 days.
In the ship.
Yeah, well, how else?
Drinking Tang. I'm just saying, drinking Tang and sitting there.
3 days. Yeah, 3 days.
3 days. Okay. All right. I'm glad
saying.
you explained it to me because I was doubting it.
Yeah. No. Oh. You asked me if I believe it. One doesn't need to believe when confronted with evidence.
Hey, I want to talk to you about Star Talk All Access for a moment. When we started our premium subscription service, we thought fans would be more interested in getting to watch video versions of our podcast or enjoy ad-free versions of our show. But it turns out our fans' favorite part of All Access is the new and exclusive original content that we post every week. We're talking about classic videos like me and Neil deGrasse Tyson chilling in his office touching his meteorite. Oh, you heard me. Or the time Neil and Adam Savage hung out in the green room before our show at Comic-Con and talked about Star Wars, Blade Runner, A Space Odyssey, and other really geeky science stuff. Star Talk All Access is your universal hub for all the great Star Talk content you crave, all in one place, including full video of most current episodes, commercial-free audio and video podcasts, live-streamed events, insider-only looks behind the scenes, the ability to watch on Amazon Fire, Apple TV, and Roku, and, of course, new exclusive original content added every week. To get started, visit StarTalkAllAccess.com to subscribe for $4.99 a month with a 2-day free trial. That's StarTalkAllAccess.com. And as a friend of mine says, keep looking up.
This is Star Talk.
Welcome back to Star Talk Radio. I'm your host, Neil deGrasse Tyson. We sent out a survey to our fans, as we do every season, and you got back to us with your favorite episodes, guests, and co-hosts. On this next episode of Cosmic Queries, Bill Nye the Science Guy takes the driver's seat alongside comedic co-host Chuck Nice. And together they tackle your questions about planetary defense.
We're talking about planetary defense.
Yes.
Keeping the Earth from getting hit with a cosmic impactor.
A fascinating subject.
It really is, and it's important.
And important.
It's near and dear to us at the Planetary Society, the world's largest non-governmental space interest organization, of which I'm the CEO, because this is our old mission. Carl Sagan, when I was in his class, in the disco era, would talk about the Tunguska event, where June 30th in the modern calendar, 1908, Tunguska region of Siberia was hit with something. It blew down all the trees in a moment. And if that had happened in a big city, that would be the end of the big city.
Yeah.
Be it. And so since then, long after Carl Sagan's class, Chelyabinsk, also in Russia, got with a big sparky thing, and a much smaller event, but nevertheless recorded on countless cameras. And so it's something to think about. Don't want to get hit with an asteroid.
Yeah, you don't.
With that said, Chuck,
and judging
welcome
from,
back to the show,
thank
listener.
you, sir. And those two events make me think that maybe Russia should be a little more involved in this.
The thing to keep in mind about Russia, first of all, let's say we take the Earth and divide it in half by hemispheres. It's going to hit one hemisphere or the other.
Okay.
That's 1 and 2. Then Russia takes up 9 time zones.
Yes.
It's it's more than a third of the world.
Right. So,
Or that former Soviet Union. So if it's going to hit someplace, it's likely to hit
there. Yeah. There or the Pacific.
Yeah.
That's about it.
True fact, not a false
There
fact.
you go. All right.
I say true fact, that's a joke, everybody. Ha ha.
Let's go to Anna Bacon. The Doomsday shows but about asteroids. Let me just start this.
Yeah, just do it without the breaks between every word.
That I
Slow talkers of America.
Exactly.
Yeah.
Okay, so Anna Bacon says this. The Doomsday shows about asteroids always have it hitting the planet, but what would happen if the asteroid passed between the Earth or the Moon, or if it hit the Moon instead of the Earth?
Well, we've photographed asteroids hitting the Moon.
Aha.
Yeah, I mean, small ones. The asteroids are manageable ones. Yeah. And asteroids have passed closer to the Earth than the Moon's orbit. That's happened.
Right.
2012, I believe, is the last one. Mm-hmm. So if you like to worry about things, this is great for you.
Right.
So far, the ones that have passed that close have been relatively small.
So now this is let's take a extinction level size object. All right.
Listen to your fluency. Extinction level size. How big is extinction level size there, Chuck?
Let's go with something like Apophis. All right.
Apophis, which is the Greek, named for the Greek god of anxiety.
Which is perfect.
Yeah.
And hits the keyhole, barrels towards Earth, instead plows into the Moon.
I guess it would be troublesome moon-wise, but I don't think
would that do anything to us?
I don't think so. I am sure people have run this computer model.
Okay.
But I don't know it. So I imagine it would just disturb the orbit of the Moon, rather than it's almost certainly would not be catastrophic life ending on the Moon because the Moon seems to be lifeless. But that's a great question. I'm sure people have run that test. And then would it deflect? You know, the Moon is slowly spiraling away from us.
Yes.
Could it be hit hard enough to start slowly spiraling toward us? I don't know. I don't think so.
Like a pool table. That'd be not awesome. What am I talking about? That'd be the end of all of us.
Well, not right away. You'd probably have several millennia to give it some thought.
And you know what? And you'd have some really beautiful nights in the meantime.
Yeah, and I just shudder to think of all the babies I just can't even.
Yeah.
It would be wild. All right,
here we go. This is Ian Coleman, and Ian says this. Hey, Bill. Huge fan here. I was wondering about the possibility of NASA's controversial EM drive being something that could actually work. Apparently, leaks have confirmed that this is it's at least moving along well. And they're even saying that it may work. Could we use this in planetary defense?
I don't know what an EM drive is. Electromagnetic? What's that?
No, it's...
Now, there's ion drives. And there's this nuclear weapon idea where you explode a nuclear weapon behind your spacecraft every few seconds for a while to get these pressure waves of particles that push you through space. But I don't know what he means by EM drive, if he means electromagnetic.
No, I think it's supposed to be some kind of new rocket engine.
Well, that's what I mentioned, the nuclear thing. Yeah. Then the other one that we're all hot for is... solar electric propulsion, SEP, solar electric module. So this is where you have something like xenon in a liquid form.
Ooh.
Put in a big scuba tank there on your spacecraft. Use solar power from photovoltaic panels to make electricity. Ionize, strip the electrons off the xenon, have a grid akin to a window screen, and shoot the xenon out the back of the spacecraft really, really, really fast. And we do that. We have ion drives right now. Just everybody wants to build a big one, a really big one. And it takes a lot of xenon, but the other thing, it takes a lot of electricity. And when you get things that big in space, it's just getting everything in alignment is tricky. But here's the idea. Although each atom of xenon or argon or whatever inert gas you're going to use, or element you're going to use, although it is very low mass, each individual atom, they're going so fast, 24/7 out the back of the spacecraft, that you can go really, really fast. Much faster is generally presumed than you can with just a regular chemical rocket, because it never stops.
Right. So it's on all the time. That's actually cool.
And we use ion drives, but people want to build a really big one.
We'll close out this Time Capsule episode by remembering one of your favorite conversations of the season, according to the year-end survey. Astrophysicist and host of PBS Spacetime, Matt O'Dowd, stopped by the studio to help us discuss the intersection of innovation and policy. Check it out.
I want to ask you a simple question, overly simplistic, but your answer, I think, who knows what it could change. So, if you were given the right, the power to direct the entire flagship science program of an entire, let's say, administration, the moonshot of a given administration, it's going to be billions of dollars worth, but you only get to choose one thing. What would it be?
What do you mean choose one thing? Choose one destination?
Well, I'm not talking about necessarily traveling anywhere.
Choose a thing to get a nation to do.
Exactly.
Okay. So, first of all, this is a democracy. People vote for things, for people, and I value that. I guess we're also a republic in a way, but votes matter, okay? And as an educator, I will not presume that I have the right to take a country to a place that I think would be a fun place to take it without the full backing of everybody who votes. So my power that you've just granted me would not be to just steer the bus. It would be to walk up and down the aisles of the bus, teaching people the value of exploration, the value of knowledge, the value of moving a frontier beyond wherever it may have stagnated. Then I go back to the steering wheel and I say, where does everyone want to go? And then they all collectively say, space. They might say something else, and I'll respect that. But I want at least a shot at convincing them that space exploration is one of the greatest forces that can operate on our science literacy. Imagine knowing that your country is about to colonize Mars or lasso a comet that has fresh water, or to mine an asteroid or deflect an asteroid that might be headed our way. And I need the best chemists and the best biologists. Maybe there's life on Mars that we'll discover. I need the best biologists. I need the best aerospace engineers, mechanical engineers, electrical engineers. I said chemists, geologists. All of the entire portfolio of STEM fields are represented in a space mission. So that's a space mission that's ambitious enough. So, and we know that the engines of tomorrow's economy, the engines of tomorrow's growth economies, have as their center innovations in science, technology, engineering, and math. So in a democracy that is also a capitalist system, when nobody wants to die poor, space exploration is one of the most potent ways to stimulate this kind of thinking in a country. So you can turn a sleepy country into an innovation nation by doing this.
By having innovation and a dream in the right direction?
A dream in the right direction that's hitting the headlines every day. Because if you're going to expand a frontier like this, you're going to have to innovate. You're going to have to invent. Patents will be awarded. That entire frontier will be new. And that is what stimulates discovery. So I would say, so you want to give me the power, I would want the power to convince people that that might be a cool thing to do.
Okay.
And then you implement the policy.
Gotcha. And so with space, it's hard. It's extremely hard to do. That's part of why it's so inspiring.
Not because they're hard. No, I
We
messed
do
it up.
because they're cool.
Okay, we're starting.
All right, no, that's good.
We choose to go to the moon, not because it's easy, but because it's hard.
Okay, and
I think I got that right.
And it's the right thing to do. All right, so the policy is implemented. Do we go asteroid mining first? Do we build a colony on Mars first? Do we go back to the moon first? Venusian cloud cities, anyone?
So I have a slightly different view of that. I want to call it a contrarian view, but it's definitely a different lane that I'm driving in. It is, why think of destinations in order? Why think of a destination as a goal? Why not let your goal be access to the entire solar system? Let that be the goal.
Okay.
And if that's the goal, then you build ships that have different combinations of boosters. You pull this one off this shelf, and this combination gets you to Mars. This combination, you chase the asteroid. This other combination with this payload, gets you to the backside of the moon. So the goal is your capacity to explore, not the destination. And when you build the capacity, you then can be responsive to the creativity of everyone who's there. This is the difference between a computer that solves one problem and a computer that can solve any problem.
Sure.
Any problem you can think of. So don't come to me saying, do we go to the moon first or Mars first? Or you do it all. You've been listening to Star Talk Radio, and I've been your host, Neil deGrasse Tyson. Join us next time when we kick off a brand new season, season 9, with more science, comedy, and pop culture. That's all for now, and as always, I bid you to keep looking up.